Group theory. In modern algebra is the study of groups, which are systems consisting of a set of elements and a binary operations that can be applied. This requires that the group be closed under the operation. The combination of any two elements produces another element of the group, that it obey the associative law, that it contain an identity element which combined with any other element leaves the latter unchanged, and that each element have an inverse which combines with an element to produce the identity element.
The axioms or basic rules for a group are closure, associativity, identity, inverses, and commutativity. Closure. If A and B are in a group, then A star B is also in the group. A set is said to close under a given binary operation star if for any two elements from the given set, the result from the binary operation is a member of the set. For example, the given set of real numbers. The set of real numbers is closed under addition, subtraction, and multiplication. Associativity. If A star B star C is equals to A star B star C, where A, B, C are elements of real numbers, then the binary operation star is associative. Associativity is defined as when more than two numbers are added or multiplied, the result remains the same, irrespective of how they are grouped. The following example shows that addition and multiplication of real number is associative.
Identity. There is an element A of the group such that for any element AO, the group A times E equals E times A equals A. Identity. The natural element of a group is often called the identity element if the operation is written in multiplicative notation, while it is called the zero element or null element if the operation is written in additive notation. The symbols for the identity element is E or sometimes O, but you need to start seeing O as a symbol rather than a number. O is just the symbol for the identity, just in the same way E is. Inverses. For any element A of the group, there is an element A minus 1 such that A times A. 1 equals E and A minus 1 times A equals E. Inverses. The group contains inverses if we have an element of the group, there's another element of the group such that when we use the operator on both of them, we get E, the identity, in just the same way for negatives. Integers, the inverses are positives. Minus 5 plus 5 equals 0. So that inverses of minus 5 is 5. An inverses of an element is another element in the set that when combined on the right or the left through the operation, always give the identity element as the result.
It is said to be commutative or abelian, a group in which the result of applying the group operation to two group elements does not depend on the other in which they are written. That is, the group operation is commutative.
That's it. Any mathematical system that obeys the four rules is a group. The study of systems that obey these four rules is the basis of this theory.
Subgroup is a group it contains with a bigger one G. A subgroup of a group G is a subset of G that forms a group with the same law of composition. For example, the even numbers form a subgroup of the group of integers with group law of addition. A cyclic group is a group all of whose elements are power of particular element A. This is a group that is generated by a single element. It is a set of invertible elements with a single associative binary operation, and it contains an element G such that every other element of the group may be obtained by repeatedly applying the group operation to G or its inverse. Each element can be written as a power of G in additive notation. This element G is called a generator of the group.